Hello, in this video I'm going to give you a very brief introduction to your quiz 10 material. This material is two modules, module 3.4 which is rectangular coordinates in 3 dimensions and 3.5 which is vectors in 3 dimensions. So the good news is that for this quiz you really just need to practice a bit about getting used to getting familiarized with coordinates in 3 dimensions, and then you are going to build upon what you learned in your previous quiz material, so module 3.2 and 3.3, and it's just extending your formulas and everything with one more coordinate. So it's basically the same as the previous material, but with one extra coordinate, which is pretty cool. So let me just tell you a little bit about graphing in 3 dimensions. So instead of R2, you are going to consider R3. And so one of your axes is going to be your X, the other one is going to be your Y, and the other one is going to represent your Z, or the last coordinate. And just for you to get used to a vector, say if your vector V has coordinates, use this one, A, B, C, then you want to measure here the quantity A, in Y your quantity B, and in C your quantity C, but you want to go parallel to your axis. So for example, the vector in R2, so in your XY coordinates, A comma B will be kind of like this. This is the vector A comma V comma 0, because I'm in the plane XY. And then I need to go up by C. So I go up, and again parallel to this. So your point ABC is going to be here when you include the perspective. So my vector V altogether, this one, remember it starts in the origin and will go like this. Okay, so that's the main idea about like graphing in rectangular coordinates in 3 dimensions. You want to practice a little bit more, but your textbook has really good examples, better than anything that I can work out here in the board. And about vectors in 3 dimensions, you have a very similar idea as before. You have, as before, you have your vector addition and subtraction. And you have your scalar multiplication. And before doing any of the operations, you want to first write the scalar form for your vectors. So say you have your vector V that goes from the point A to the point B. Well, now, because A and B are in 3 dimensions, say A is going to have coordinates A1, A2, A3. B has coordinates B1, B2, and B3. And then I didn't mean to say scalar form, sorry. This was supposed to be algebraic form. The algebraic form of your vector would be B1 minus A1, B2 minus A2, and B3 minus A3. Okay, so after this, you can add them, or you can multiply them times scalars. So for example, and say this is going to be a v1, v2, and v3. If I do something similar with my vector u, and say I have a u1, u2, u3, then u plus v, and all of these were arrows, but sometimes I don't take the time to write the actual arrow. It's just going to be, once they're already in the algebraic form, you can just add or subtract component-wise. So this will be v1 plus u1, v2 plus u2, v3 plus u3. So similarly with subtraction, similarly with scalar multiplication, so you just multiply your constant in each of these. And the magnitude, let me put that here. Of b is going to have the same notation. And my formula is only slightly different. I just need to add a third term. So if my vector v in its algebraic form is v1, v2, v3, so that's going to be the square root of v1, quantity v1 square plus v2 square plus v3 square. And that would be the generalization for this. So again, if I want to try to build a unit vector with the same direction as v, the only thing that I need to do is take v and divide it by its magnitude, and that will give me a unit vector in the same direction as v. Opposite direction would be changing the signs for the opposite signs that v has. So if you want to see more examples related to this material, we have videos already posted in our Canvas site. So in particular, I have videos for problems type 3.51, A and D, and 3.52A. So check those videos. Those will help you to have more examples and understand problems that relate to this material. But as I said, the good news is that this is basically just a generalization or an extension of the theory that you have seen already for your quiz 9. So I hope that this helps you.